It was much more exciting than I thought. You see the flames. Our first video of fluorine was a bit disappointing. There wasn't any, just a few bits of glassware and some funny stories. So at the moment I'm in the office of Professor Eric Hope.
There he is.
Who is one of the country's specialists in fluorine chemistry, and he knows how to handle this terrific element safely. I have no idea what to do. I'm quite excited to see what happens.
One of the things you said in that original video was on YouTube was that fluorine was one of the few elements that you hadn't seen. So I thought there are actually relatively few chemists who have seen fluorine, and so what I want to do is try and show you actually produce and show you elemental fluorine. The fluorine is slowly released, and you can see the pressure slowly going up.
The reason that people know about fluorine is because it is one of the really reactive elements. It will react with all the elements in the periodic table except neon and helium. It will react with gold, it will react with silver, it will react with platinum. Platinum hexafluoride is bright red as a gas.
Okay, so fluorine is going into the apparatus, it's going into this tube. Martin, you can't see anything, can you? You can't see anything at all. And that's because there's only a little under 2 atmospheres of fluorine in there. It's a very pale yellow colour as a gas.
A bit disappointed, but I suppose it's like oxygen or nitrogen, you can't really see it. But perhaps if we condense it as a liquid, then I'll see it properly.
Okay, so I'm now going to cool this down with liquid nitrogen to minus 196. I'm going to do it slowly. It will take a little while. Okay, Martin, do you want to help me with this?
Yes.
So what I want to do is for you to take that jar away, and then I'll slide this one in. So just slide it away and back up again. And there we have, nearly 2 inches maybe of liquid fluorine. You can go right up, there's no problem with that. If you want to just clear a bit of the condensation off there.
Yeah, I'm really surprised. I thought it would be pale green, and it's really quite dark yellow. If I'd been shown it, I would have said it was liquid chlorine. But I've never seen liquid chlorine either.
I'm quite pleased with that. Yes. So basically I've got another fluorine cylinder filled up from the roof with about 5 atmospheres of fluorine in it. So this is now going to release the fluorine, and what I've got in this demonstration here is just a scouring pad. Basically it's a metal scouring pad, iron wool.
It's burnt a hole right through the iron wool. It's extraordinary. The iron looks as if it's rusted, but the rusty colour is actually iron fluoride, or maybe a bit of iron oxide from the hot iron reacting with the oxygen in the air. Well, the reason that fluorine makes such strong bonds is because it is a small atom, and the nucleus is relatively highly charged because it's right on the right-hand side of the periodic table, but the electrons don't shield this nucleus, so it is very so-called electronegative. It attracts electrons to itself from other elements.
I've changed the prop now for some just normal barbecue briquettes, so this is pure carbon.
So we haven't done anything. This is cold charcoal and cold gas, and the gas just touching it is enough to start the fire. Think of that, just the cold gas setting things on fire. Most chemists are really too frightened to work with fluorine. You can't use it in glass vessels. It doesn't attack glass, but if the glass is a tiny bit wet, and most glass has moisture absorbed to it, then the fluorine forms hydrogen fluoride when it reacts with the water, and the hydrogen fluoride just eats through the glass. So you need to use equipment made out of metal, usually nickel, and the fluorine reacts with the surface of the nickel the first time you use it, and then you get a layer on the surface that protects the rest of the metal.
So this is again fluorine with sulfur, so you're going to oxidize the sulfur probably to sulfur tetrafluoride or sulfur hexafluoride.
Fluorine has this reputation for being very reactive and very dangerous and something to be careful about. But aren't there fluorine atoms in my toothpaste?
Your toothpaste contains fluoride. And just in the same way that you can eat sodium chloride table salt, which contains chlorine, you can use fluorides, and once the fluorine has got an extra electron, for example, from the tin in tin fluoride, which is often used in toothpaste, or sodium fluoride, it's got what it wants, and it's not very reactive. And the way it works with teeth is that the enamel of your teeth is a compound of calcium called apatite, which normally the apatite in your teeth can dissolve quite easily in acid. For example, if you eat sweets or drink some fizzy drinks, they have enough acid to start dissolving the surface of your teeth. But if you brush your teeth with fluoride, some of the apatite, which contains OH groups, some of these are replaced with fluoride, and you make a material called fluoroapatite, which is much less soluble in acid, so it can't be attacked so easily, so you don't get holes in your teeth.